All right, so let's continue with the solving rational equations, part 3. Just a review quickly of the process. So if you have two fractions, in this case rational expressions, if the denominators of the two are equal to each other and we have an equal sign in between, that means the two fractions are the same, or two rational expressions are the same, you can assume logically that the numerators are the same, and that's what this is. Okay, and that's what we're going to use, which is a little bit easier. You don't have to worry about too many algebraic operation. All right, first thing first, we need to put everything into factor form if we can, left hand and right hand side of the equation, and then we come back and continue. Let's do the factor form first. Okay, we put the left hand side, the numerator of the left expression, into factor form, and you realize that at this point, because of this trinomial is not factorable anymore, then you're done. And at the same time, you also realize that there's nothing that we can actually divide. So even though we did the factoring, in this case it may not be useful, but we have to do it anyways. All right, now we have to basically come up with the LCD, and LCD is very simple in this case. LCD is 2x minus 1, because the right expression, right hand side of the equation, the denominator is 1. So now we're going to multiply top and bottom by first fraction is just going to be by 1 over 1. We're not going to do anything with that. But the second, on the right hand side, we have to multiply that by 2x minus 1. Now we're going to go ahead and rewrite this just using the numerators, since the denominators are now the same. Excellent. So here is on the left hand side, I'm just going to write the original. I'm just going to go back to original, which is this one right here, because the factor form is not going to help anyways. So 2x squared minus 2x plus 8, which is right here. I just did that. And then the right hand side, you have x plus 1 times 2x minus 1. You have to actually FOIL that out, or distribute. And then when you do that, you get this top part right here. Okay, and then you simplify it, you get 2x squared, and that's plus x minus 1. Now we're going to collect like terms, bring x's on one side, numbers to the other side, and then polish. Let's go ahead and do that. Okay, so the idea is to put all the x's to the left hand side, into left hand side, and then numbers to the right hand side. But right now, let's do one thing at a time. We're going to deal with the x's first. I'm going to leave the 8 alone. So subtract 2x squared from both sides, subtract x from both sides, and that's what you will get. Minus 2x minus x, that minus 3x, 8 comes down. And on the right hand side, minus 2x plus 2x, that's 0. X and x, that's 0. You get minus 1. And then the last thing we got to deal with, we have to deal with the minus 8. So, sorry, positive 8. We have to subtract 8 from both sides, and then the final answer for this, or final part, will be minus 3x equal to minus 9, and then divide both sides by the coefficient of x, and x will be equal to 3 in this case. All right, so once you have the 3, and that's the final answer, you make sure you check it. And remember, you have to check it against the NPV. In this case, we didn't do the NPV, but the NPV is basically this denominator, 2x minus 1. 2x minus 1, set that equal to 0, so x equal to half. That's your NPV. So that's good. And then the other one is that you check it against the original equation. Make sure that the left-hand side is equal to the right-hand side, and then you'll be done. All right, let's look at this new rational equation. Let's go ahead and put all the denominators into factor form. Okay, when you put all the denominators into factor form, that's what you will get. A review of the factoring method. All right, and now from this point on, you need to come up with LCD and make sure that LCD is actually a correct LCD. So first, all of them must have x plus 2. Okay, so that's the first thing. Next one, they must have x minus 1. And last thing, they must have x minus 3. Okay, and now we're going through each of these rational expressions and then include the missing factor in the denominator, so that they all will have the same lowest common denominator. All right, so here it is. Now all of them will have the same common denominator, lowest common denominator, and since they're all the same, we're just going to equate the numerators together. So the left hand side will be x minus 3 times 3x plus 1 equals to 2x minus 3 times x minus 1 minus 5 times x plus 2. At this point you have to expand, simplify, bring all x's to the left hand side, numbers to the right hand side, and then go ahead and solve. All right, that's what you will get when you expand both top and bottom, the left hand side and right hand side, and make sure that you do expand it correctly and collect like terms. And at this point you just have to polish it more. Just keep polishing it until all the x's on the they're on the left hand side and numbers on the right hand side if you can. Great. Next step is right there, just collecting the like terms, minus 5x on the right hand side, and then plus 3 minus 10, that's minus 7. And now the last thing is that we're going to bring everything to the left hand side, all the x's, and let's see what happens. All right, so once you simplify everything, notice that you end up getting an x squared. That's a quadratic equation actually. So in this case, you have to bring everything to the left hand side and set it equal to 0, because you have to solve a quadratic equation, and solving a quadratic equation is different than solving a linear equation where you have a left hand side is x and right hand side is number. In this case, you just have to bring everything to one side, set it equal to 0, and then solve it either through factoring or quadratic formula. So this is the final equation that you have right here, and it is not factorable. This trinomial is not factorable. If it was factorable, then it would have been easy. Just put them in a factor form, set it equal to 0, and then you have to use a zero product rule. But in this case, you have to use a quadratic formula, which at the grade 10 level, that's a little bit higher than your level. But at grade 11 level, you can actually use the quadratic formula and then plug numbers in. Remember that quadratic formula is based on the coefficients of all the variables and a constant term of a general quadratic equation. All right, in this case, when you do this, you're noticing that b squared minus 4ac, or the discriminant, is less than 0. So this will have no real solution, because what will happen is that the square root, you will have a negative number, and that is not allowed, and because of that you will have no real solution. So I am going to show you why that is a negative number and that's not allowed. Okay, and here it is. I'm just plugging numbers in for the quadratic formula. You notice that you will get right here, that's a negative number under the radical. This was called discriminant, and discriminant, when it's negative, that means you will have no real solution. There is a solution to this, but it's not based on the real set of real numbers. It's based on the set of complex numbers, but you don't know what that is yet. In the near future you will. All right, and that is basically it.